to teach you two concepts that are considered non-Mendelian genetics. They're not anything super, super complicated, so I kind of fully expect you guys to pick it up super quick, and it's not going to be a problem for anybody. All right, so let me go to my PowerPoint really quick and start there. Let's go back here. Okay, so let me move my face out of the way. All right, so the first thing I want to teach you is a non-Mendelian concept called incomplete dominance. Okay, so up to this point, we've sort of been mentioning that a lot of your education has probably been centered around what we like to call Mendelian genetics, which is like very simple, dominant, recessive. And everybody uses the same letter, and it's either a capital or a lowercase combo, and all is very clear. Unfortunately, a lot of science does not work that way. And so incomplete dominance is one example where it does not. Okay. Fortunately for us, I happen to find this much easier than regular Mendelian genetics, which is already kind of simple. And so I wanted to share this with you guys. All right, so incomplete dominance is where neither allele is dominant and neither allele is recessive. They just sort of blend. And so you guys are already experts on this. You probably have been experts on this since like preschool or kindergarten, which is awesome. So long story short, all incomplete dominances is like when you take red and white and you just like mix them together and you make pink. And you feel like when you're like 3 or 4, you're like, I discovered a new color. And really you're just taking things like that and mixing them together. Or the first time you discovered that blue and yellow make green, right? Like when you were painting when you were little and you took your brush and a little bit of this and a little bit of that, whatever color they made together. The way that paint works is the same as incomplete dominance. In the green example where we take blue and yellow, it's not that the blue is dominant and it's not that the yellow is dominant. It's that they're incomplete dominance, meaning like neither one is going to just show up by itself. When you mix them together, they're gonna blend together to give you that green. And incomplete dominance works just like that. So let me get you a picture. Okay, so here are some flowers that operate with incomplete dominance. So let me walk you through what you're seeing. So here's what we call the P generation, or like the parental generation. And so we have a red flower and a white flower, and they have mated, and they had all pink babies. And then we mated a pink flower with a pink flower, and it gave us 25% red, 50% pink offspring, and 25% white offspring. So how do two pink flowers make red, pink, and white babies? Well, incomplete dominance. So what I want you to note is that right now what you're looking at, you're seeing capital R, and then capital W, capital W. And really what that means is you don't have to worry about uppercase and lowercase. They have different letters now. So red is just RR and white is just WW. And this makes total sense because when you get to pink, it's R and W because it's red and white mixed together. Doesn't that just make sense? It makes sense to me, but let me know if it doesn't make sense to you, and I will do my very best to fix that. Okay. So I wanted to go through just a couple of practice problems with you guys and explain some things. So I'm going to go ahead and move my face over here and shrink me. All right. Okay. So it says here incomplete dominance problems. In snapdragons, which is just a type of flower, flower color is controlled by incomplete dominance. So anytime that I am first learning something, or I am using any sort of word problem, if I'm reading a word problem or if I'm practicing, I like to use my highlighter or underline or help me. And so I like to guide myself so that when I go back, I don't have to reread the problem over and over again. It's a really good time saver. So I like to highlight main ideas and main concepts. Okay, so it says flower color is controlled by incomplete dominance. So that lets me know that what I'm looking for is the color of the flower. It lets me know we're probably going to have a blend at some point, like a mixing of those paint colors again, okay? All right, so the two alleles. So anytime it says that, that's going to give you your two options, okay, for traits. So in this case, it says are red and white. And it lets you know that red is going to be that capital R. Now, originally, I had this where it said R prime. I've decided that for our particular grade level and our particular level of understanding that is needed, not to teach all the R prime part. So I'm just going to mark that out. And instead, I'm going to leave that W there to let you know that W stands for white instead. If you're watching this and you're in college, or if you're in my IB class, then maybe we're talking about R and R prime, and I'll try to make y'all a separate video, or the college students a separate video when we get there. However, for my precious high school babies, don't worry about R prime. Okay, so it says the heterozygous, so I'm going to do this, heterozygous is expressed as pink. Okay, so let's go through. All right, so A, what is the phenotype? So remember, phenotype is that physical appearance. What is the phenotype of a plant with genotype RR? That's going to be a red plant. Well, I guess a flower. It's going to be a red flower. Okay, what is the phenotype of a plant with WW? That's going to be a white flower. All right, what is the phenotype of a plant with the genotype RW? Well, red and white make pink, so that's going to be a pink flower, just like those flowers we looked at on the PowerPoint. Okay, so let's scroll down and work on this practice problem. It says a pink flowered plant is crossed with a white flowered plant. So let's go up in here. A pink flowered plant is crossed with a white flowered plant. What is the probability? So they want probability of producing pink flowered plant babies. Okay, so if you look up here and use A, B, and C as your guide, it'll make your life a lot easier and quicker when doing this. So a pink flowered plant, if we go back, what is the phenotype of a plant with RW? That's pink. So in this first one, we write an R and a W. I write them in all caps, okay? So just capital R, capital W. All right, so it's crossed with a white flowered plant. So if you need to go back up here to see, our white flower friend is capital W, and there's no lowercase or anything like that in incomplete dominance. So I just like to write in all caps. Okay, so how does it want us to do this? It wants us to do a Punnett square, just like always. You never get away from those Punnets. Okay, so remember, it doesn't matter which parent that you put where. So I just put whoever's listed first on the top and then whoever's listed second down the side. And then you just fill it in. Ta-da! Okay, so it wanted to know what are the what's the probability of producing a pink flowered plant. So remember, pink is just RWs, so we're just looking at RWs. So it looks like they've got a 50-50 here. So 50% chance of getting a plant that is pink from this cross. Okay, so there's some more practice problems on your worksheet down here. I did not make your worksheet. I found this one, thank goodness. But it was really nice. It's kind of a simple going. Yeah. So if you have any questions on your worksheet, please just email me and let me know, or drop a comment on Google Classroom or something, and I will do my best. Okay, so let's jump back to the PowerPoint. All right. So something else that I have to teach you that is just as simple and easy is called codominance. Okay, now codominance is where both alleles are fully dominant and physically there. So we're used to something being, present and showing up in the phenotype if it's dominant. But in this case, they both do. They're both going to show up in that phenotype. So you see this in blood typing with type AB blood. So A and B are codominant blood types. And so they both show up in AB blood. They both have those little antigens in the blood. Okay, so here is an animal example. So this is codominance in horses, and I don't actually know anything about horses. This is just a picture example that I found. But in this case, it's showing us that one of the horse parents is brown and one of the horse parents is white. And then this is a picture of an offspring that could have come from that combo. Now, in codominance, you cannot predict the pattern very well. And what I mean by that is it kind of looks like the front of this horse has been dipped in chocolate, or the back of the horse has been bleached or something, like painted white. So we don't actually know the pattern. So it's very rare for an animal to be like perfectly split down the middle like this with the pigments, but it's still really, really cool. So my favorite codominance occurs in snakes. Now, I don't actually love snakes very much, but I find snake genetics very, very interesting. So some snakes are codominant. So I wanted to show you guys, just Google on the internet here, codominant snakes. And then let me move my face. And then we go to images. Okay, so if y'all can see, this is a cross that includes one parent that's an albino snake. And including one parent that's an albino snake is actually pretty common in snake breeding. And so I think snake breeders just think it makes really cool combos, which I'm not going to lie, it's pretty cool. So you don't know where the albino part is going to show up in a codominant snake and where the pattern piece is going to show up. And so each scale is inherited independently of one another. So, I mean, hypothetically or theoretically speaking, each scale could potentially be different. Now, that's not usually how nature plays out. Nature likes to put things in patches. And so you'll see that a lot, patches of colors and things like that. Here's another one that I love. So this one, you can see what I'm talking about, how like one single scale or two scales right there have a pigment, but the rest of the scales around it are albino. And you can see another little spot down there. It's just so cool. They just have so many cool, oh, that one's really neat. So this one's albino except for the head, and then the head inherited all of that pattern. So cool. Oh my goodness, there's so many neat codominant patterns. Snakes are also really cool to look at incomplete dominance with, because snakes have such unique and specific color inherited patterns that no matter whether you're dealing with codominance, like in our picture here, or if you're dealing with incomplete dominance where things are mixing, honestly, snakes are really cool to look at. They're just really neat to study. Okay, back to our practice problems. Okay, so let me scroll out of the way. Here we go. Okay, let me shrink myself again. Okay, so in some chickens, the gene for feather color is controlled by codominance. So I'm going to take my handy dandy pen again and say codominance. That way I don't mess this up. Okay, the allele for black. So it's telling you that black is an option, and it's telling you to use the letter B. and the allele for white. So white is our other option, and it's coded for with a W. So we're still using two different letters here, still in all caps. A heterozygous, so let's say that it's heterozygous, is known as erminette. An erminette is a black and white spotted chicken. They also call these checkerboard chickens, and it looks like the tile on like old 50s diners. Let me see if I can. Erminette chicken. There we go. And so there you can see an erminette chicken. It just has white and black spots. And so they call that erminette. Okay, so what is the genotype for a black chicken? So if you look up here, it tells you to use B for black. So if it's a black chicken, it has to have two capital B's. Okay, and then if it's a white chicken, it's big W there. And then the genotype for an erminette, so that's just a black and white checkered pattern, is capital B, capital W, okay? And it basically works just like that. So let's do a practice problem. Let me move my face here out of the way. Okay, number 3. If two erminettes, okay, so let's write that down. Erminette, so that means that they're black and white, black and white. All right. Now I get asked a lot, how do you know? Because if they both use capital letters and they both use, in our instance, two different uppercase letters, how do you know if it's codominance or incomplete dominance? And basically my easy, quick answer is that you just have to read the problem, and the problem should always tell you if it's codominant or incomplete dominance, like in the description of the question or the scenario. Because otherwise, there's really not a clear way unless it just described codominance or it described incomplete dominance to you in a sentence instead of just saying co. If it said something like, and both alleles show up in the phenotype equally in patches or in speckles or in stripes, then that would let you know it's codominant. Okay, so I'm going to be quiet for just a second and fill this in, and then you guys fill yours in at home. There we go. Okay, what's the percentage they would have a black chick? So this one is black, so it looks like 25%. And then that they would have a white chick, so there's the white chick, and that would be 25%. So two of those checkerboard erminette chickens, if they mated together, could still have 25% of their nest could be black, 25% of their nest could be white chickens, and then 50% of their nest is likely to be that checkerboard cool pattern. Okay, that's pretty much it for these concepts. Usually the places in our life that we see codominance the most is going to be in flowers and in things like cattle, so cows or horses. Some of those have a codominant pattern. Horses are tricky though, because horses and cows also, some of them have incomplete dominance. It just depends. I do, and this is silly to say, but I have to make it clear because I get asked every year, this is not how zebras are made. Okay, there is no white zebra and black zebra making a striped zebra. All zebras are striped, okay? We also see this in flowers a lot, so I thought I would show you some codominant flowers real quick. Oops. Okay, so these are some of my favorite to look at. So codominance in flowers is really neat. It sort of looks like they've been like tie-dyed, or they're artsy and patchy and they're a mess. Sometimes they're really neat and like almost precise looking, and sometimes it looks like a hot mess, and I just love it. I actually planted some, I'm such a nerd, you guys. I planted some codominant roses a couple years ago to bring in to show my kids, and they're actually the pink and white ones, just like we're looking at. And each bloom was different from the rest. So I had some blooms that were white totally. I had some blooms that were pink totally. And then I had a bunch of blooms that all had different patterns where it was pink and white patches together. There was really no rhyme or reason. Here's another really cool one where it literally is just like split down the middle. Here's another one down here where it's just split down the middle. Having a really even split like that is kind of rare in my opinion. But others have very predictable patterns of inheritance. So here's a good one where it shows you the difference between codominant and incomplete dominant. So you've probably seen these around like a grocery store in the outdoor section, or just sort of any market or flower bed where you could see these, but they're really common flowers. But you can see where these are hot pink in the middle and then white on the outside, or red, I guess. And then this one, which is incomplete dominance, which is what we learned earlier, is like a mix. Here's another one where it has a little more of a predictable pattern of codominance. And so it just sort of depends what, like here's one that's not very predictable, but I think is still really, really beautiful. So anyway, I just wanted to share some neat codominant plants with you. Okay, let's go back to our worksheet and make sure I covered everything. Okay, so I think that's it for us. If you guys need anything, just let me know. Hopefully this helped you. And once again, if you're in like a college class or my IB bio class or an AP bio class and you're watching this, instead of using two separate letters, you would use something like B and then B prime. But I'm not going to cover that in this video. All right, I hope you guys have a wonderful day, and email me if you need anything.